Okay, this is a special kind of factoring that you can save a whole lot of time if you recognize. It's called difference of two squares, or difference of squares. Think about this, difference means subtraction, so it has to be a subtraction problem. And squares, this in particular, means a perfect square. So before we get started, over on the side, I want you to think about some perfect squares. Okay, we'll move this over a little bit. We're talking about perfect squares. I think it's a while that before we talk about these, or since we talk about these, this means simply this. 1 squared is 1. 2 squared is 2. Speak to me. Okay, we're going to talk about difference of two squares. If you look at the top, and specifically, we have special case of difference of two squares. Think about difference means subtraction, and squares means a particular type of number. So look over to the edge. Let's put a list of squares here. Trying to get you thinking about those again. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 we have 16. 25 used a lot. 36. 49. And we can continue going as far as we need to. 8. You should have them memorized through 100. And I think we even talked about, at younger ages, 11 and 12. And then there's a couple of that you should know. 15. We use this a lot, geometry. 225. 20. It's 400. Okay, so those are a list of squares. What we're interested in, we're trying to look at problems that specifically have these numbers. Because if we have those numbers, it's really easy to find the factors of those numbers. For example, if we look at this, if we were to multiply this together, when we did this with multiplying polynomials, we use the FOIL method or we use the vertical method, and you come up with this. Because our negative 5 and 5 cancel out. Well, in factoring, like on DCF, it's going the opposite way. Well, this came from here. Like, okay, well, where did the middle two terms come from? This one is x times x. This is a perfect square. So we go there on our list, it comes from 5. So this is 5 times 5. The only thing we need to do to cancel it out is have one positive or negative, because this gives us 0 in the middle. So it says, notice that the middle terms are canceled out. When we're multiplying. This will always happen when you have difference of two squares. This is your rule right here. You have a squared minus b squared, because x squared is the square, minus b squared, whatever that number is, and you have the difference of two squares, and it's easy to write the same term in parentheses, 1 plus, 1 minus. Okay, so look at x squared minus 16. Okay, x squared is a perfect square, x times x. 16 is a perfect square, 4 times 4. So we simply need to have 1 plus, 1 minus. And that would give us x squared minus 16. We're going to leave 2 and 3 for just a minute, because it has extra steps that we have to do. Here we have x squared minus y squared. Notice they're all subtraction that we're going to work really easily. Here's our x's, here's our y's, 1 plus, 1 minus. You're going to have a whole lot of these on this page that you can do that, even if it has an extra number in it, like say number 6. The number in front of x squared. The 121 from our list was 11. 11x, 11x, 1 and 1, 1 plus, 1 minus. Now, not every problem is already fixed for us. Sometimes we have to fix them. So, if we look, for example, at number 2. Number 2 will work as long as we take out a 3. Just like we did with greatest common factor. 3 is in common. We have left x squared minus 9. We have to keep this 3 out here. But x squared minus 9 is the difference of 2 squared. 2x's squared minus 3, 1 plus, 1 minus. This entire thing is our answer. And you need to make sure that you factor it completely. You can't just leave it 3 times x squared minus 9. And you can't try to find 3 times something and 3 times 9 to get you 27 in this parentheses. You have to factor it out. Okay, this one is plus. Notice here, we said when we did GCF, greatest common factor, that the first term had to be positive. So if there's a negative here, we're going to take it out. Let's take out that negative and see what happens. Take out negative 5. We have x squared, and 5 goes into here 25 times. We want this to be positive. To make that positive, this has to be subtraction. So we're going to keep the negative 5. Square root of 25 is 5. 1 plus, 1 minus. And that number is not always going to be the same out front that it is right here. That's just a coincidence. Say it could be a 2. It could be anything out front. Number 8 is a little different. What I always know number 8, if you look at this and you notice that this is a perfect square and this is a perfect square, but it's not difference. 8 is negative 9x squared plus 25. You can rewrite this 25 minus 9x squared. And we could turn it around. That way we have a difference of 2 squares. The x term doesn't have to come first. And we can have 5 and 5 minus 3x plus 3x. Another way you could do that is you could factor out the negative 1. We have negative 1 and then 9x squared minus 25. You can have your 3x minus 5, 3x plus 5. But you'd have to have the negative 1 out front. Either one of those would be acceptable. That's our difference of 2 squares.